So it's your third class. Formally, once again, Assalamu alaikum. And we'll begin the third lecture of this session. So what are we going to do today? Again, very, very brief revision. And then we'll continue with the numericals. So what we did yesterday, we have done problems, two problems related with inclined plane, right? Those of you who were present yesterday, they have done it. So very brief. So in problem number 14, what is the case there? That a cyclist is going up a slope. A cyclist is going up. And what is the angle of the slope over here? 30 degrees the slope, right? And what is the speed of the cyclist? 3.5 meter per second. Now what he did, the cyclist stopped pedaling. Obviously the car, the cycle would stop. So we have to find the distance that the cyclist has covered before coming to rest. I repeat, cyclist, the speed of the cyclist is 3.5 meter per second. What is the angle of slope on that inclined plane? 30 degree. What he did, he stopped pedaling. So it means his final velocity would be 0. And before coming to rest, he will cover some distance. We have to find that distance, right? And what is the important factors here? We assumed here that the friction force is 0. So the data, since the cycle is going up, that is why we have taken the value of G in negative minus 9.8. Now to find distance, acceleration is must. So we'll find acceleration first by using the formula A is equal to G sine theta. This is the formula for inclined plane, for the acceleration of inclined plane, right? We have substituted the values and got the result of minus 4.9 meter per second square. Then we have done the distance we have found by using the formula 2A is equal to VF square minus VI square. And finally, we got the result 1.25. Means the cyclist would cover only 1.25 meter after he stopped pedaling. Same sort of question, but instead of cyclist, a car is there. And the angle is 45 degree. And what else? The speed of the car is 63 kilometer per hour. So we converted 63 kilometer per hour into meter per second. Again, the value of G is minus 9.8. VF is 0. Frictional force is 0. Same pattern would be followed. First, we will find A, acceleration. Then we substituted the value in this formula and we got this. So that was done yesterday. The next question is very much similar to this question which you can see on the screen. The only difference is that here we assume that the frictional force is 0, but in that case, the value of frictional force would be given to us. Means, see, question. How far will the car move before coming to rest? If it weighs 19,600 Newton and the frictional force is 2,000 Newton. So it means here we can't suppose that the frictional force is 0. All right. So when we were doing the topic of inclined plane, just recall your memory. We have got a formula there. A is equal to G sine theta minus F upon M. So this formula we'll use here in this problem. Why? because the frictional force is given. That is why we will not use the simpler formula A is equal to G sine theta, but A is equal to G sine theta minus F upon F, as you can see. Secondly, one more thing. Here the weight is given. 19,600 Newton is the weight of the car. But since the formula is there, A is equal to G sine theta minus F upon M. M means mass of the body. So we'll also convert weight into mass by using the formula W is equal to mg. So what would be the scenario? We have to find the same distance. Our formula 2as is equal to Vf square minus Vi square. To find this, we need acceleration. Okay? And the acceleration on an inclined plane with friction is A is equal to G sine theta minus F upon M. M is needed. M can be calculated from W is equal to mg. So we'll convert weight into mass first. Substitute into A is equal to G sine theta minus F upon M. And then finally, the last one, 2as is equal to Vf square minus Vi square. Okay? X equals to minus 2 upon 2, yani minus 1. So see the data. Angle is 45 degree, 63 kilometer per hour. As I told you yesterday that we'll convert 63 kilometer per hour into meter per second. 63 multiplied by 1000 divided by 3600. Simplifying it, we'll get 17.5 meter per second. I hope you know it. Then the value of G minus 9.8 meter per second square. Final velocity is 0. Weight is 19,600 Newton. Frictional force is 2,000 Newton. These are the two additional parameters which were not there in the previous problem. And again, we have to find what? The distance. All right. So as I told you, first we will convert weight into mass, right? So to find the distance, we'll need the values of M and A. What is M? Mass of the body. What is A? Acceleration. So how can we find mass? W is equal to mg. What is the value of weight here? 19,600 Newton. So we'll change this formula for mass with M is equal to W upon G. Substituting the values. The value of W is 19,600 Newton. The value of G is 9.8. And the mass of the body comes out to be 2,000 kilogram. So what is the mass of the car? The mass of the car is 2,000 kilogram. Okay. Now we'll write the formula for acceleration with friction. A is equal to G sine theta minus F upon M. This is the difference. In the previous one, there wasn't any friction, so we just used A is equal to G sine theta. Clear? Here, A is equal to G sine theta minus F upon M. Substitute the values. 9.8 sine 45 minus 2,000 divided by 2,000. Simple? It's so simple. 2,000 would be cancelled. And the value of sine 45 is 0.707. 2,000 divided by 2,000 will give you 1. That is why it is mentioned there. So you can see over here, 1 is the answer. Now, multiplying 9.8 by 707, it will give you minus 6.928. Adding these two values will give you minus 7.928 meter per second square. So it's the acceleration. It's the acceleration. Clear? Now, as we did earlier, using the third equation of motion, we'll find the distance. 2s is equal to vf square minus vi square, making s as the subject. The formula has been changed, substituting the values. Velocity is 0, final velocity is 0, initial velocity is 7.5 square, and then acceleration. Simplifying it, the square of 0 is 0, the square of 17.5 is 306.25, multiplying 2 by 7.98, it will give you minus 15.856. Subtracting 306.25 from 0, it will give you minus 306.25 divided by minus 15.85. And finally, the answer is, minus minus cancel, the answer is 19.31 meter. So in this case, since the frictional force is there, the car will cover just 19.31 meter before coming to rest when the engine of the car is stopped. So see the next question. From the concept of momentum, recall your memory, the product of mass and velocity is called momentum, and the formula we had, m1u1 plus m2u2 is equal to m1v1 plus m2v2, law of conservation of momentum. So what can you see over on the screen right now? That there's a 100-gram bullet, right? And that 100-gram bullet is fired from a 10-kilogram gun. So we have two bodies over here. One, the mass of a bullet with the mass 100 gram, we'll convert into kg. And we have another body, gun, its mass is 10 kg. Initial velocities of both of these is 0. Initial velocities of both of them are 0. So what else is given? This when the bullet is fired. So what is the speed of the bullet is 1000 meter per second. As you fire the bullet will go in the forward direction, whereas the gun will go in the backward direction. This is called the recoil of the gun. When you fire a bullet, the bullet will go in the forward direction and the gun will go in the backward direction. This is called the recoil of the gun, right? So what is the data over here? Mass of the bullet, 100 gram. The mass of the gun is 10 kilogram. Dividing 100 by 1000, it will give you 0.1 kilogram. Okay? Initial velocities of both of them, of both of these bodies are 0. U1 is equal to 0 meter per second. Initial velocity of the bullet, initial velocity of the gun. Final velocity of the bullet is 1000 meter per second. And the final velocity of the gun we have to find out. Okay? So according to the law of conservation of momentum, m1u1 plus m2u2 is equal to m1v1 plus m2v2. Substitute the values and get your answer. It's so simple. If you know maths a little bit, it means you can do it by yourself very easily. Substituting the values, m1 0.1, u1 0, m2 10, u2 0. The same values. Multiplying these two, 0.1 multiplied by 0, 0, 10 multiplied by 0, 0. On the right side, we multiplied 0.1 by 1000, it will give you 100. Okay, now 0 plus 0 is equal to 0. Change the side. 100 would be transferred on the right side. So it becomes 0 minus 100. Since we have to find the value of V2, so multiplied by 10 would be transferred to the right side as divided by 10. And the answer is minus 10 meter per second. The negative sign shows what? Does this negative sign shows? It shows that the gun is going in the backward direction, in the opposite direction. Okay. So what is the speed of the gun? 10 meter per second. What is the speed of the recoil of the gun? Is 10 meter per second. So these are the two problems. Tomorrow we'll do another problem, one or two problems. Then the this chapter would be over. Friday you will give a practice test of all the problems of chapter number 3. We will continue with the problems of chapter number 3 and then the test. Take care. Thank you so much. Allah Hafiz.